So welcome to the day one of this very interesting topic, that is limits. So we are going to talk specifically about limit of a function. So it all begins with the main name, that is functions only. So now since we have already done functions in detail in grade 11 as well, so now we are going to understand, we are going to dive deep further into this basic name that was functions. So in today's class, the task is to understand this new name, that is limits. Specifically limits of a function, limit of a function. So what's the meaning of this? Let's first understand the basic logic. So now this is the interesting part. So just listen to every word very carefully. So let me first start with a very interesting, very simple function. I'm just taking a very simple function to make you understand the logic. So let's say I've taken a function f of x is equal to x plus 1. F of x is equal to x plus 1. Now if someone asks me that what is the value of f of 1, or f of 1. So for f of 1, I know the graph of this function as well. If I have to draw the graph of this function, I know that this would be a straight line. This is simply y is equal to x plus 1, which is a simple straight line. So this would be the graph of this function. Let's say this is the line y is equal to x plus 1. So if someone has asked me the question that find the value of f of 1, then I simply know that it means that on the x-axis I have to locate the point x is equal to 1, and I have to look for the corresponding value on this function. So that would be the value f of 1. So this is f of 1, the value of the function when we take x as 1. So f of 1 is actually this value over here. So we can find the value of f of 1 which can be simply solved as well. So this is actually 1 plus 1, which means 2. So if we exactly go at that point, if I exactly go at this point x is equal to 1 on the x-axis, then we can see that the corresponding value of y, which is f of 1, becomes 2. 1 plus 1, that is 2. Now instead of taking x as 1, now just assume this simple, just listen to this simple story. Let's say instead of taking x as 1, I am now approaching 1. Now x is not 1, x is coming close to 1. So let's say if x is 1.5, just as a simple value, if I'm now, my target is to actually approach 1 ultimately. So if I have taken x as 1.5, what would be the value of this function? So f of 1.5 would be what? It would be simply 1.5 plus 1, that is 2.5. So I'm coming more close to this number 1. Let's say if I've taken x as 1.1, I'm coming very close to it. So if I'm taking x as 1.1, so by taking x as 1.1, it is somewhere over here. So by taking x as 1.1, the corresponding value of this function at that point when x is 1.1 would be 1.1 plus 2, that is 2.1. Now I'll come more close. So let's say I'm trying to come more close to this number 1, but I don't have to reach 1. I just have to come as close as possible to this number 1. So now I'm taking x as, let's say, 1.05. The value of this would be 2.05. If I take the value of x as 1.01, I'm coming more close. Just notice this thing. This would become 2.01. I'm coming more close, but I don't have to take the value of 1. I don't have to take the value as 1. I just have to come as close as possible to 1, and I'm coming from the right side. Just notice this as well. So I'm coming more close. So instead of taking x as 1.01, now I'm taking x as 1.001. So what would be the corresponding value of this f of this? Simply by filling, I can find that this would become 2.001. If I make it more close, it becomes 1.00001. So there are 4 zeros now. So the value would be 2.00001. I'll come more close. F is now the function, the value of x is 1.0000 and so on. Let's say 20 times zeros and then 1. So the value of f of this would be 2.00020 times and then 1. So now this is the story which you have to actually focus upon. Without actually taking the value of x as 1, just by coming closer to this number 1 as close as possible, just standing at the gate of this number 1. So okay, just imagine this is the number 1 and you're just standing at the gate of this number 1. So the number just after this is actually x is equal to 1. So by just looking at the behavior of the values that are coming, just by looking at the values, the behavior of the values that are coming, what can you say that what would be the value of f when x is equal to 1? You don't have to go to that number. Just by looking at the previous pattern that is happening, you just have to judge that what would be the value of this function f if I take the value of x as 1. So you just have to judge while you are just standing at the gate of this number 1. So just by coming closer to closer, we can see that the value which I am getting is 2.01, then 2.001, then 2.00001. Can we directly say that by coming very close to it, we can say that, okay, the way values are coming, we can fairly assume that if I take x as 1, then the value at that point would be 2. So now I am not exactly going at that point. I'm just coming as close as possible to this number x is equal to 1 from the right side. So without exactly going to the number, by coming very close to it, as close as possible to it, the value that we would feel that this value is going to come at this number, that feeling that which we are getting about the value of that number at that point, that feeling is the limit of that function at that point. Just listen to this very carefully. Without going at that point, by coming as close to that point as possible, the feeling that we get that, okay, this would be the value of this function at this point. So that sense by the previous pattern, that sense of the value that we are getting without going at that point is the limit of that function at that point. So in this case, limit of, if I just write it down, limit of fx at x is equal to 1 is 2. So in this case, value of the function at x is equal to 1 was also equal to 2. But now it looks like that both these things are same, but we'll go further into the topic after this, and then we'll understand that what is the difference. But the first task is this, that we should be very clear in our mind that what does exactly limit of a function at a point means. So limit means that we don't have to go at that point exactly. We have to come as close as possible, and by looking at the previous the pattern of the value that the pattern of the values that are coming, we have to judge that what could be the value of this function at the point just after. So that judgment, the judgment of the value that we are getting in this case is actually the limit of the function at that point. So limit of this function fx at x is equal to 1 when we are coming from the right side is simply 2. So in this case, if I write it down, it is written in this manner: limit, which is lim x approaching 1, x is not equal to 1, f of x. This is the way we represent a limit. Limit, which is simply its abbreviation is lim, which means lim x approaching 1, f of x in this case is equal to 2. But now the interesting part is this, that in this case we have approached 1 from the right side. Now let's play the same game from the left side. Now